Origami is an art of paper folding. Ori to fold and kami means paper in Japanese language. In this video, let's explore how to make a sine wave using paper folding. The concept is taken from the book written by Sri Sundarrao Sir in the year 1893. The title of the book is Geometrical Exercises in Paper Folding. Let's take an A4 sized paper, make a vertical crease at one side and perpendicular to that at the center of the paper make a horizontal line, and the point of intersection, let us name it as O, and let's mark a point A which will become the wavelength of our sine wave. It can be any point. Let's bisect OA and mark it as B. Our full cycle is of 360 degrees, O to A, and B is the point of 180 degrees. Now, between this x-axis and y-axis, we have 90 degrees. We are bisecting that. Now we got two 45 degrees angles. Further bisecting them, we shall be making that 90 degrees into 4 equal parts, 4 equal angles. These are the 4 equal angles. Now let's mark a point on the y-axis that forms the magnitude of the sine wave, and let's mark the same point on all the lines which form the 4 equal angles. Now from these points, let's make horizontal folds to the x-axis. Now let's bisect OB to form the 90 degrees point. As we have divided this initial 90 degrees into 4 equal parts, we will be dividing OB into 8 equal parts, as B is the point of 180 degrees.
Now from these marked points, we shall be making the perpendicular lines to the x-axis. Now let's observe the points of intersections, that is the peak value of the sine wave, and this is the point of 90 degrees. Let's see the point of intersection. This is the point, and further going with the other intersections, we are marking the points. Now let's join these points with the folds. We got half cycle of the sine wave, and let's mark the points which are marked on above the x-axis. Those points are marked below the x-axis also, which will be helping us to form the second half cycle of the sine wave. Now from these points, let's make the parallel lines to the x-axis, horizontal folds. As we have considered OA to be 360 degrees, OB is 180 degrees point, and between B and A we have the negative peak of the sine wave, and let's mark that 270 degrees and the peak value. And similarly, the horizontal and vertical lines intersections are being marked as shown. The points are shown with pen just for visibility. Now let's fold between these points. Initial 90 degrees, if it is folded into more number of equal parts, we can get a smoother sine wave. We have divided that initial 90 degrees into 4 equal parts, we can experiment with 8 equal parts and 16 equal parts so that the sine wave will be more and more smoother. So we are able to see the sine wave formed. Happy folding, viewers.